All right, well, I want to thank everybody for coming, and I guess we'll hand off to Bob Tarsio for his presentation. And I haven't talked to Bob about what exactly we're doing tonight, but my guess is that there will be questions at the end. So if you have something, use the chat or wait for the end.
Well, you can interrupt me. I'm used to that. That's fine. Okay, so I want to thank everybody for attending, and you know, we have as I say, three BDI either alumni or people here tonight. And as I said before, Jennifer is really the author of most of what you're going to see tonight, as far as the demos and whatnot are concerned. So I may direct some questions to her. We'll see what happens. But just a real brief before I bring up the PowerPoint. I want to, well, I don't know, Frank, I guess I don't know whether you can see this or not now, whether you can see me, but.
Yeah, I just got home, so I'm going to head in the house. Oh, my God. HLR 100. Wow.
He's the only other guy that knows what this is. This was our first product. As a matter of fact.
I know exactly what it is. I installed a bunch of those.
Oh, okay. Very good.
Line amp for the Gates Executive?
Yep.
Yeah, that's what they are. They're program amplifiers for the Gates Executive. We also did a mic preamp, but I don't have any of those. We sold them all. This one actually, you can't see it, but it's marked prototype. This was the first one. So Frank sent me this. I didn't have this. He sent it to me. So
that's my handwriting on that. Yeah, I kept that as a memento. Yeah.
That's your handwriting. Yeah, that one has the earliest date on it. It says 20th week of 86 it was produced. But we actually started the company a year before. We had to get designs going and get things going. So it was in the 85 is actually when we started. So we started with that, and here we are today, 35 years later, still building some audio products, but we've really delved into the RF side of the business in the last 12 or so years. And that's really mostly what I'm going to talk about tonight, although I'm going to touch on audio a little bit. So I got a PowerPoint, but Dan, you had asked me to maybe change it up a little bit tonight, because some of the folks that are on here I saw in Baltimore back pre-COVID, was right in February. And so that's essentially that presentation, but I'm going to change it up a little bit because I want to show some of the new product a little bit and showcase that and talk a little bit about Flash and its demise here at the end of the year, and what you can do about that as far as BDI products are concerned. So without further ado, let me get the PowerPoint going here. And I am going to need to share my screen here, so let me do that. Well, let's go back here. I got to pick. Oh, it says the host here has disabled the screen sharing. So whoever the host with the most is, you're going to have to let me do that.
You're muted, Eric.
I thought that I was allowing screen share, so let me take a look at that.
Well, I can talk in the meantime. So basically, I'm going to talk about three basic topics tonight. You know, power measurement, RF power measurement is one of our primary product lines. So I want to talk a little bit about calibration standards and percents of error and that kind of thing, and how we derive those standards. I think that's an interesting thing to talk about. And then I'm just going to do a very brief introduction on simple network management protocol and how to manage things in SNMP as it relates to some of our products. And then I'm going to follow it up with an audio topic, which is, I'm not sure that, I'm thinking about maybe after this presentation, I won't emphasize this as much, but the AES or multiplex over AES standard that a couple of the audio processing companies have developed, some management of that in the transmitter plant, and how to do that successfully. So those are the basic three topics I'm going to talk about. And then I'll do a little show and tell. I'll show the new power meter, the DPS 100D Generation 2 power meter, firmware and software, and also our new remote control, the SWP300 remote control. So let's see if
Bob, I cannot see any reason why you can't share. See if you can share now.
There we go. All right, so there's so many things to choose from here. Let's use that, and let's share that. Okay, so let me get this started. Start from the beginning. It's always a good place to start. Okay, so again, I've covered this. This is what we're going to talk about tonight. So again, I talked about that. So there's 2 slides right down right there. So let's get into the first slide. I want to talk about accuracy, and or actually probably more accurately, errors that you can have in accuracy as it relates to RF power measurement. Now, I used to do a presentation that was mostly about how our meter worked and why it was different than other meters and that and whatnot. And I will certainly answer any questions about that anybody has. But what I really want to concentrate on tonight is how we derive our accuracy measurement, or actually our percent of error measurement. We have a stated specification for all of our power meters that they are guaranteed to be accurate within plus or minus 5% of indicated reading. So how do we get that plus or minus 5%? And that's really what this is about. Well, with most things that you want to be able to ensure that there's a high degree of accuracy with, there's usually some sort of a standard that you can compare what you have to what you want to calibrate against. So in the United States, we have this great organization called NIST, the National Institutes of Standards and Technology, that is in Gaithersburg, Maryland, I think, right? Not too far from you guys. As a matter of fact, I've been there. It's quite a place. It was a long time ago, but I've actually visited there. And I was there for a conference, actually. I didn't get to see any of the really cool stuff that they do. So, you know, you can just about anything that you might want to have calibrated. Well, it could be a thermometer, it could be a strain gauge, it can be just about anything. They probably have a procedure and they have a standard for it. And RF power measurement is no exception. And I did a little investigating into this, and there's a number of papers that NIST has published over the years about methodology, about how they do it, and what degree of accuracy that they can come to tell you what your device under test is within the primary standard. And what it all boils down to is that you can send a meter to them. Let's say, for example, we could send one of our meters off to NIST. I've never done it, by the way, because of the expense of it, and I'll tell you about that in a second. But you can send it, and they'll measure it, and they'll say, well, this is what the percent of error is from the standard. However, the percentage of error from the absolute standard to what we're measuring your device to be will be within plus or minus 1%. So what that means is they can't tell you any better than about plus or minus 1% really how close it is to their standard. That's pretty good, by the way. You know, you got 99% that you know, is active accuracy, and 1% is the error. Well, that's a primary standard. Now, I mentioned cost before. Now, if you wanted us to send one of our meters to NIST, we'd be happy to do it and send you the bill for it, but you probably wouldn't like it. The cost of doing that, the last time I checked into it, was about $5,000 for them to, you know, give you a NIST certification or traceable standard, to a primary standard to that particular device, let's say, that you'll put in your transmission line. And I don't know many stations that can afford to do that at this point. A lot of stations can't even afford power meters. So, you know, to tack that cost on top of the power meter is a little prohibitive. So what many manufacturers have done, and we're no exceptions, we've developed secondary standards. So we're moving down this little triangle of doom, as I call it, because the bottom of the triangle is where, you know, the rubber meets the road, you know, the meter in your transmitter room. But we're gonna get there eventually. So if you notice on the left-hand side of this presentation, this slide anyway, we're stacking up differential errors. So we've visited NIST, we've been to Gaithersburg and back, and we know that we now have a plus or minus 1% error is the closest that we're going to get to a traceable standard. While the laboratory standards that we use and other companies use, and they may vary in which type that they use, is the next rung of the triangular ladder here. That's the yellow, the lab standards. Now, what is a lab standard? And that's what we use here at BDI to calibrate your power meter, your RF sensor, at least the RF sensor part of it, because there's 2 parts of the calibration, and I'll talk about that in just a second. Well, there are two principal methods for secondary standards that are used. One is calorimetry, and anybody that's worked in television is probably very familiar with calorimetry. It's essentially measuring a physical property of purified water. If I remember my college thermodynamics properly, I think that it takes about 4.124 calories of energy to raise 1 milliliter of water by 1 degree Celsius. So you can extrapolate that out to, you can convert the water temperature into calories, or go to temperature, and we'll look at the temperature differential of a water channel and convert that heat change in the delta in temperature to kilowatts. And that's a very, very, very accurate standard, using very purified water through a channel. But, let's think about what we're doing here, and let's look at some of the sources of error to that. What's the purity of the water? What is the flow rate through the channel? What is the accuracy of the thermometers that are being used for the inlet and outlet temperature? So all of these things stack up to add errors. And if you'll notice, there's another set of errors on the left-hand side there, another plus or minus 1%. Now, that's calorimetry. We don't use calorimetry. We use another standard, which is basically a calibrated reference standard, which is nothing more than a signal generator that has an NIST traceable calibration. It basically says the level of that output of that calibrator is going to be within a certain percentage of error. And guess what that percentage of error is? Plus or minus 1%, about 0.05 dB. It's the same for calorimetry. So what this really means is once we've calibrated an RF sensor and we measure back, we can measure the actual absolute, let's say, simulate, because what we're really doing is we're simulating the output of the directional coupler at the precise level that we expect from the directional coupler for a given power level. And then we're looking at the actual indicated power based on that. And when we do that, so for example, we use a 60 dB standard, for example. So 0 dBm is 1 milliwatt. So plus 60 dBm would be 1 kilowatt. So if you use 60 dB of loss, for example, that means that you're going to measure 1 kilowatt full scale. What's coming out of the coupler will be 60 dB down from that, or 0 dBm. So if we take that 0 dBm signal from the signal generator and we carefully look at that, we can tell how close to 1 kilowatt the meter will actually indicate. Our standard is plus or minus 1%. We generally come well within 1% of the calibration standard. So, okay, that's part of the calibration. Now, let's move down one more rung on the ladder here. We're down to other lab and test equipment and fixtures. Well, what we sell is a through-line power meter, and this is an interesting thing. We're compared very often to, companies like Keysight and Rohde & Schwarz and Ritsu, people who make power sensors. They make power meters, but they're really not a through-line power measurement system. They make a set of electronics and a sensor that plugs in, and they can measure at low level very precisely signals. But you need to have a thing called a directional coupler if you're going to measure through-line power. Another source of error. That directional coupler, you have to know the frequency response of that, the couple port of that directional coupler with very high degree of accuracy in order to put it all together and have an accurate power meter. So what do we use to do that? Well, it's another piece of test equipment. It's called a vector network analyzer. And that analyzer is subject to the same calibration standard, perhaps traceable to NIST. And if you look at standards for the specifications for most of these analyzers, there's, again, another familiar tune here. It's about plus or minus 1% is the best they can do to guarantee the output of the signal generator within the analyzer and the measurement capability. So if you're adding up these errors, we're up to about 3% already. In other words, that's the maximum delta. Okay, so let's keep moving down the ladder of doom here. Other effects, such as temperature variability, handling, and long-term effects. Well, we've measured our meters under tests from freezing to 150 degrees Fahrenheit. And we know that the typical change in indicated power will be about 1% over that temperature range. And that's normal. Now, most of the time, you're going to keep things in a constant temperature, but we do have to take into account that there is temperature variability. And so the other things are handling. Well, once you get the meter and you install it in the line, there's usually some little bit of manhandling of that meter when it's installed. So we have to take that into account, that perhaps the geometry of the through line, a couple port to the actual center conductor may change just very slightly when it's being torqued down and when it's being installed. So another little bit of uncertainty there. Then there are the long-term effects of aging of components and that kind of thing. So we're going to tack on another 1% for that we know about. So we're up to about 4%. So when you get to the field comparison, now this is where the rubber meets the road, and this is what we get the most telephone calls about. Now you've installed your BDI meter in your transmission line, and you're now looking at your transmitter, and you're looking at the BDI meter, and you're looking at your transmitter, and you look at the BDI meter, and they don't agree. And I get these phone calls. I got one today, as a matter of fact. And a guy says, well, my transmitter's putting out this much power, and your meter's reading lower than that. I said, well, what's between the two meters? Well, there's a switchless combiner, and there's some transmission line, and it's warm in spots. I said, well, there's where your power's going. In other words, there are other effects. So the difference was, I calculated it for him. He gave me the power readings for the 2 meters, and it was about 5% delta between the two. But let's think about something. If you've got 4 or 5% error in one meter, and that other meter that you're comparing it against probably has the same delta for maximum error, they could add up in the wrong direction. You have to assume that they will. That means that you could have a plus or minus 10% delta between 2 meters, and they're both within specification, and that would be considered normal. Now that's not typical, because statistically we know that these things generally average out. So guess what? That was well within the statistical error, having a 5% delta. Although there was one other little piece of the puzzle that was missing. They had disassembled the directional coupler to change the bullet around, which we tell people not to do. As a matter of fact, we put a calibration sticker on it. Do not disassemble the directional coupler, because that'll spoil the calibration, which in this case we think it did, and that probably owes to most of the error there. So when I was saying about handling, that's the other part of this. So the thing is, I told this guy today, I said, if you ever get 2 meters that read the same, run out and buy a lottery ticket, because you got lucky, because it's almost it's almost a physical impossibility that they're going to read identically. They can be very close. Typically, it's within a few percent of one another, but there is a reason why we have these kinds of standards, and why you have to have a percentage of error. So I think that's it on this particular thing, but I got some more things to say about directional couplers, so let's move right along here. I mentioned the directional coupler earlier, that it's a pretty important aspect of through-line power measurement. Now, we don't actually build our own directional couplers, although we had a hand in designing them. We specified what they're supposed to do and how they should be made. And so we have, let's see, 1, 2, 3, 4 manufacturers that can build directional couplers for us. And as a matter of fact, I have a few of them here. Here's this is a 3 1/8 inch, and this is made by a company called P-Cube, which is up in Maine. Do a little show and tell here while we're at it. This is a new one. This is a DIN style. We've been making the DIN coupler, but this particular meter has a different style of directional coupler on it that has a very flat. So this is 80 to 1,000 megahertz with no slugs and nothing to change. You put the frequency in that you want to measure, and it calibrates to that frequency. And this, as I said, is a DIN style. We make an N style as well, and we make all the EIA sizes up to and including. If I don't drop my microphone here. I show this because a lot of people don't realize we make meters this big, but this one's 6 1/8. I don't have the actual electronics mounted to this, but this is a 6 1/8 inch. And these are typically, we shipped a couple of them last week. One of them went to a television station, and another one went to an FM combined output where unfortunately the antenna blew up, and they decided that having VSWR protection would probably be a good idea for the new antenna. I think the insurance company actually insisted. So that's another aspect of this. But anyway, I wanted to talk a little bit about the directional coupler itself. There are principally 3 different types: bidirectional, also known as a balanced coupler, and a lot of the couplers that we use are bidirectional types. It's basically what you're looking at schematically here is that you have basically a pickup loop inside, and it has a termination on both ports. So let's say the forward side here, we actually don't use 2 halves of a coupler like this to do forward and reflective. We do it with the same port. We feed the forward port sample to the forward port input on our meter, and then the reflected port goes to the reflected port sample, and they're both 50 ohms termination, so inherently they're balanced and isolated. So that's the first style. Then there's the unidirectional or voltage sample. I'll talk a little bit about that in just a second. And then the compensated or frequency compensated with termination type coupler. This particular coupler here on this meter, to do 80 to 1,000, you have to do a termination, and you have to have a network in there that's going to flatten the response. The bidirectional coupler, basically because of the capacitive nature of it, it has a 6 dB per octave rise in response. So you have to sweep it and know the band of interest that you want to use it for, but it offers the best directivity, and I'm going to talk about that in just a minute. Unidirectional coupler, voltage sample. We've all seen these, probably used them. Pardon me. That's essentially the BNC connector that's on the corner of an elbow that's supplied usually by the transmitter manufacturer, intended to be used to drive a modulation monitor or something like that. I don't even think they're good for that. I don't really know what they're good for, because a voltage sample is nothing more than simply a small antenna. It's just a piece of wire inside the coupler itself, or the transmission line, and it's not terminated in any way. So it has 0 directivity, which means it can accept a signal equally well in both directions. And we're going to find out here in a minute that that's not really necessarily a good idea for certain uses. Well, you notice that these couplers are schematically shown as dual port. We use 1 port for the meter, and then the same directional coupler can have a 2nd port, and that's an option that we sell actually, so that you can have a measurement port, which is also a balanced coupler on the other side. So you can have an identical set of ports, and you don't have to have 2 directional couplers to do that. You can do all of that in one line section. As a matter of fact, we can supply up to 3 additional ports. So you can basically essentially a 4-port coupler, but we use 1 for the power meter. So we supply those a lot to television stations and combiner systems where they want to look at things at different frequencies and whatnot. So, and everybody wants to have their own port to do that. So I have down here directivity, the amount of attenuation from 1 port to the other. That's typically what directivity means. Typical value for broadcast use is we spec 30 dB or better on our couplers. Why is that important? Well, I'm answering the question before I even get to the slide, or asking the question before I get to the slide. Let's take a look at a typical example. I'll try to run through this very quickly. Let's say we're not so concerned with power measurement at the moment, although it's going to have its impact on power measurement. This is an example of AM noise. If you want to measure synchronous AM noise or static AM noise of an FM transmitter, we use a directional coupler sample to do that, an RF couple sample. Now, I said earlier that our couplers typically have 30 dB or better directivity. Sometimes they're closer to 40. But let's use an example of a directional coupler with a typical directivity of about 20 dB. That means that the signal that the reflected port will see that from the forward, the incident direction is going to be at least 20 dB down and vice versa. So in this example, I'm using a nice round number like 10 kilowatts here. So the antenna, and let's assume an antenna return loss of 2 dB, which will return about 63 watts. But let's remember something, that the reflected power signal is subjected to a round trip time, because it's unlike the forward signal that the directional coupler is measuring, which is right right after the transmitter. That reflected signal is going up the line and bouncing off of some of it's bouncing off the load and coming back down the line again. So there's going to be a phase shift between the incident and reflected signal. Now remember, they're both going to combine at some level, and if it's 20, if the directivity is only 20 dB, so you have directivity plus the antenna return loss, you have to add those two things together. So you're going to end up with essentially about a 42 dB noise floor to make your measurement with. Well, that might lead you to believe that your transmitter needs to be tuned, if anybody still does that, or that there's something wrong in the system somewhere where maybe there's a bandpass filter that needs to be touched up or something. But you might want to wait a minute, because if you take that same directional coupler and replace it with one with 10 dB better directivity, what did I win? I just heard a bell go off. Now you have a noise floor of 52 dB. So you were never going to measure anything better than 42 with the 20 dB coupler, but now you can see at least a 52 dB noise floor. So it's your dynamic range of measurement has been improved by at least 10 dB. And so you can actually see what the transmitter is doing at that point. So it's not a limiting factor. I think that's it on the RF power stuff. I showed you the, oh, there's one more thing I wanted to show you. We get this question a lot. I have a bird line section that I want to replace your meter with. How hard is it to do that? Well, I'm going to show you that it's not hard at all. Here's a bird. Everybody's seen these, you know, slugged kind of a line section. This is a 3 1/8 inch. Let's see if I can do this where you can actually see it. They're exactly the same size. So very little plumbing involved. You very little you have to do to swap one of the older style meters out with the new meter, and that goes for all of our EIA line sizes, whether it's 1 5/8, well 7/8, 1 5/8. We do 4 1/16, but in addition to 3 1/8, but 4 1/16 isn't an EIA standard, and 6 1/8. I wonder how many people knew that 4 1/16 is not actually an EIA standard. It's kind of a bastard standard. Okay, so that's the only other thing I want to do. Maybe before I do this, I want to just talk briefly about SNMP. Let me. I want to share the screen here. I want to just stop here and do a little show and tell on something. Let me do a new share. And where are you? You gotta just take a second here. Let me
Bob, while you're looking for that, your discussion about the power meter calibration call that you got made me think of, I don't know how many different general managers that would tell me, well, which power meter reading do you like the best? You know, which one do you believe?
Right.
The one that allows you to turn up the transmitter the most.
Yeah. That's pretty much it. I'm having a little difficulty here figuring something out here. I want to close, well, I don't want to close this out. I want to minimize this. Well, I didn't want to do that either, but that's okay. I can figure this out. Okay, so I just wanted to show the new DPS 100D power meter while we're at this. Okay, I got that. There it is. I got it. Now all I got to do is share that. Okay, how do we do that again? Here we go. New share, resume share. Let's do a new share. And now I have that up. Well, now I have it in 2 places, but that's okay. So, can you all see that? Can you see the actual app, the DPS 100D app?
Still seeing the SNMP slide that you brought up before.
All right. Well, I didn't do something right here. Hang on 1 second. Let's try.
You may want to stop share and then start share.
Yeah, that's probably a good idea. Oh, Stop. I don't want to stop video. I want to. Oh, here we go. Yep, you're right. Okay. Let's start over again. Okay, let's do that. Oh, here we go. How's that? You see that now?
Yeah.
Okay. Yep, we see the app.
We got 2 of them up here at the same time, but that's okay. So this is the new power meter, basically monitor screen. Now here's the big difference between a lot of you. I noticed a lot of familiar names and faces on tonight. So your customers, and you have some of our power meters. You know, and if you have our DPS 100D power meters, you know that you use a browser to access the meter and to control it and set it up and do all of that. Well, with the demise of Flash, which we depended on, all of our product lines use the Adobe Flash Player runtime to operate, and it was a very, very good system. It allowed us to very rapidly deploy various pieces of software, but sadly that's coming to an end. So about a year and a half ago, we got busy and started to redevelop the product line. And so with the power meter, which we've been building for about 10 years now, we've done a couple of things. We've obviously changed the look of it, but we've also changed some of the operation of the meter and made it more accurate. So this is basically the setup, which is an app that runs that's provided with the meter. We don't charge any extra for that. It comes free of charge with the meter, and you just load this. There is a browser interface for the initial setup, but that's HTML5. So we have eliminated the requirement to use Adobe Flash in the power meter. Now, one thing I also want to mention, we have an upgrade program for anybody that has an existing DPS 100D and they want to upgrade to the Generation 2 firmware and get a calibration out of it. We are offering that. Actually, we're doing that through our dealer network. So, contact me tomorrow or whatever if you want some more information about that. Rest assured that one thing I've been getting a lot of questions about, and what I should answer here, is that what's going to happen on December 31st or actually on January 1st. Probably not much of anything. I think first of all, your meters are going to continue to operate even if you don't do anything, because most of you, I think, are probably using the SNMP, pardon me, part of the meter to talk to it either through our BDI Stack app or from the using it with a third-party hardware like a Burke remote control or any other software that is an SNMP manager. Let me just take a sip of my. This is what happens to me when I talk too much, which is why I try not to talk too much, but my wife says I still talk too much. So this is basically the main screen and some of the little changes that we made here. Previously, you got forward reflected power, but you had to make a choice between whether you wanted to display reflected power or VSWR. So here now we're showing it simultaneously. You can also change that VSWR indication if you want. You can go in here and you can have, oops, where is it? Oh, it's in display. You can change the VSWR to reflective power indication, VSWR, return loss, or row. So we can get a return loss. Let's see if that's, there you go. There's a return loss of 32.25 dB as opposed to a VSWR 1.05 to 1. That's a pretty good match. We made that change. The look of the screen obviously is a little different. It's a little, it's laid out a little bit more evenly. Still have the set points for thresholds for alarming and that kind of thing. We're showing a couple of things that are in alarm here. Because we have the maximum forward power set for 18.7 kilowatts, and look what the power level is. It's 46.2. This is actually a customer's unit that's under test here, and that's actually what the full scale indication is. So 6 general purpose inputs, that remains, and then we have this transmitter on and off function, which I don't want to go through the whole thing on this, but I just wanted to show that this is what we're doing here. And the setup is very easy. You just go through various pages and set up what you want to fault. Well, there's a VSWR fault. We've got that check mark. Oh, here's another very important thing that we added. Previous to this, we only, the 3-strike counter, which is the reflectometer that's in the meter, reacted only to reflected power. And we did that for a couple of reasons. I won't going to go into all of them, but a lot of combined sites where you have a lot of ingress from other antennas and whatnot, using VSWR isn't the best indicator because you're going to get ingress from other antennas, mutual coupling. We had a situation in Chicago where we delivered a system about 10 years ago where they had an IBOC antenna, separate IBOC and analog antenna, and the IBOC antenna was getting as much ingress from the analog antenna as it was putting out forward power. So if we had set it for any kind of a VSWR, it would have been tripped all the time because we would have had an infinite, it literally was the same amount of reflective power coming back from the other antenna as there was, pardon me, forward power. So we had to use reflected power for that. So that's how we got started with that. But we've had a lot of customers ask us, well, look, you know, we really want VSWR. So we added that now. So if you go into the RF setup page, you can set a fault for VSWR. And over here on the remote page, you can select whether you want it to trigger on VSWR or reflected power. If you deselect it, it's reflected power. And if you set it for VSWR, it's VSWR. So we added that. And otherwise, the meter operates pretty much the same way. Although I would tell you that the, one very, very important thing that we changed here. If you notice, there's a frequency indication here. So that's the meter is calibrated right now to 102.3. If I want to change that to another frequency, I can do it in the field using SNMP. And the reason we did that is because lots of folks want to take these meters from location to location, and they don't want to have to send it back for factory calibration. It's not necessary because the meter is calibrated on every FM channel. And you can change it to any frequency that you want within the FM band, and it's going to remain accurate. So that's something that we added that's new. And I don't think anybody's doing that. I don't think our competitors are well, I don't think our competitors have put any money into power measurement, new technology of power measurement in some time. So we continue to try to push the envelope on features. So anyway, I'm going to get rid of this for right now. I just wanted to show you that we haven't been napping. And by the way, if you want to do the upgrade, this is what you get. You get a fully upgraded meter as long as the we'll check the hardware out. We do a calibration, and we give you the new firmware and the new software to run it, and it's all for one price. And again, you can contact your broadcast dealer about that. That's the DPS G2U for Generation 2 upgrade. That's what the part number is, and they can give you a quote on it. And I won't do any more of a sales pitch on it than that, but you might want to know about how to do that. Okay, so I'm still sharing the screen, and you're seeing all this stuff, and I'm going to show you this in a little bit. This is the remote control, but let me, let's get back to the PowerPoint. So let me do a, let's stop the sharing for a moment, do a new share, since that seems to be working better. What happened to my PowerPoint? Oh no, I think I lost my PowerPoint.
For meters that were purchased relatively recently, is there any sort of discount for that upgrade, or is it all the same?
Yeah, if the meter's within, yes, I didn't point that out. If the meter's in warranty, if it's under a year old, we do it for free. We send you an RMA, and you send us, and oh, by the way, you don't have to send us the whole meter. You just send us the electronics. We don't need the directional coupler. And we'll tell you all about how to do that. But that's a good question. Yes, if the meter is under warranty, if it's a year old, starting at September 1, that's when we started to ship the new firmware. So if you bought a meter from us in the last year, you're entitled to a free upgrade. Okay, so you contact us directly about that. If it's under warranty, if you have any question about it, call me and call us here at BDI, and we'll tell you whether it's under warranty or not. And if it's close to being under warranty, even if it's just a little over, we're probably going to look the other way and just do it for you. So check on what you've got, and if it's a fairly new meter, we're going to do it for you for free. Okay. All right. So I got to find my PowerPoint. Just bear with me just a moment, folks. Here we go. There it is. Okay, that's back. So now let me go back here. Oops, that's not what I want to do. I want to get rid of that. And now I can't seem to get to the screen share again. What happened? Am I still here? I hope you can still hear me.
You are still here, and I don't see a reason why you can't share, but what might be easiest is if I just make you the host.
Yeah, okay. I got to get back to where I can, I want to see the meeting controls here.
Yeah, I'm going to make you a co-host, so you should have all the controls now.
Yeah, but I gotta find them. That's the problem. I can't see them now. Darn it. What's going on here? Oh, I see what's going on. Okay. All right, there we go. And where's my PowerPoint? I keep losing my PowerPoints. Just bear with me a second here, guys. Okay, that's what I want to share. So now, there we go. Okay, let's try that. Okay, see my PowerPoint again? And we want
Looking
to
good.
start from the current slide. Okay. Well, we're going to talk a little bit about SNMP, and then I'm going to go back and do a little show and tell about that because I want to bring up a MIB browser that we use to show how that works. This is like, guys, if you're really running with SNMP already and you're very familiar with it, you're going to be very bored by this. You may be rolling your eyes, so I apologize for that. But the tail end of this part of it, I'll show you, how we use the MIB browser so that you can do some troubleshooting and you can, make sure things are working. So some real basics about SNMP. What SNMP stands for Simple Network Management Protocol. And let's see, do I want to go back a slide? Did I miss something? Oh yeah, I did miss a few things here, but okay, some basic types of SNMP, V1, 2, and 3. V1 is the oldest version. Communities are set in plain text and is limited to 32-bit counters. And it's not really used very much anymore because of the security problems, because everything's set in plain text. V2 is a much more popular standard, and that's still pretty much the predominant standard. It adds 64-bit counter capability and adds some security by adding read and write communities, which you can password protect. V3 adds a layer of encryption, but we've been asked about V3, and I got to tell you, I don't see the industry really embracing V3 very much because it just gets to be very complicated to implement. And for most folks, V2 is working just fine, so that's what we're running right now. All right, some basics about SNMP. Lots of 3-letter and 4-letter monikers for things. So the MIB, Management Information Base, is where the information is. So you're running a simple network management protocol. There are two kinds of devices. There are SNMP managers and there are SNMP agents. All of our hardware are SNMP agents, and our software is the manager. And that varies from manufacturer to manufacturer, just how they do that. But that's basically how it works. So the MIB is the thing that the manager uses to go find the information that it's either looking for or how to interpret what it's being sent. That's essentially what it is. It's really a text file, and it has the pertinent information about a particular product, where things can be found, and how it can be displayed, and all the rest of it. It's basically the whole story on that. So, well, I got a few other things to say about this here. So, yeah, we use pretty much one MIB over a product line. So our SWP product line, which are our remote controls and motorized switch controllers, use the same MIB essentially. Makes it easy because you only need to load one MIB for that. Our audio switchers, same thing. Our audio toolbox series audio switchers that are all SNMP now, all use the same MIB. So whether you have an ATB300 or a GPM 300 or one of our DAB 300s, uses the same MIB to either interrogate or control the product. We have like over 30 audio toolbox versions, so trying to have 30 different MIBs to run that would be crazy. So we standardized on one to handle all of them. Was there a question? So I heard somebody say something. Maybe not. Okay. So what is a MIB? Managing within a MIB. Oh boy, this is a lot of numbers here. So I want to move this around so I can see what I'm doing here. You can't see what I'm doing. Okay, so what's within a MIB? Well, there's a thing called an OID string, an object identifier, and it's an address to identify various functions and how to perform them within the device. So I've got an example here of what a MIB looks like. I mean, I'm sorry, an OID looks like, and it's just a very big series of numbers. And you will notice that from manufacturer to manufacturer, virtually all the numbers in the beginning group there, the first 6 digits will be identical, and you can see why. each one of these numbers means something. You know, the 1 means it's an ISO group that was established the OID standard. 3 is that it's organization specified text, so on and so forth. You got the DoD has got to get their 2 cents in there because they established the internet. I thought that was Al Gore that did that, but oh well. Old joke. And then the rest of this stuff, again, is all pretty specific, and they're common to most OID strings. So then the next group becomes the company ID. And so every company that does SNMP has to register with a standards organization and be issued this company ID. So any OID string that our company uses for any product, it's got to have that company identifier in the middle there. And that's how you know that 37691, you know that's a BDI OID string. And then the rest of the string, these various numbers here, are company specific. And I have one example here, and I think this is what is this one? This looks like it's I gotta look here. It looks like it's the product identifier for an SWP controller. So just very quickly, this is the rest of this, as you see, is basically as it tiers down here to the right. You'll see this in a minute on a MIB browser. It's essentially folders where you find various pieces of information. There's a BDI registrations folder, and within that is the product categories. And you can pick a product category, and within that you have the RF product line, and then so on and so forth. So it gets down to the last digit, which is the actual SWP product. I think I can't see it because the screen sharing thing's in the way there on my screen, but I think that's well, anyway, you get the idea. It's the identification for that particular piece of equipment, which unit it is. It's an SWP 200 in this case. I think it's a 200, maybe it's a 300. So a few more definitions. And I'm going to show you what these things are and what they do here in just a minute through a browser. A couple of more definitions. A GET. What's a GET? A GET is sent from, as a command that's sent from the SNMP manager that's attempting to take information from the MIB and find out what the value of the variable is within the device itself. The response it gets back is the agent sends a response to the SNMP manager when replying to a GET request. So this provides the SNMP manager with the variables that were requested originally. And then there are a couple of variations on this. Get next just means that the SNMP manager sends this message to the agent to get information from the next OID that's within the MIB tree. So these things are ordered, so you can go sequentially through and look at each thing. Get bulk is the SNMP agent uses the get bulk message to pull tables of data. So it's lots of data from different, using different get next commands. A set is like the old fashioned raise and lower. You know, you're going to send a command and have it do something. Set is a message sent to the by the SNMP manager to the agent to change configurations or issue commands. And in our parlance, you know, you're actually going to do what are essentially raise and lower commands on a remote control. You're going to close a relay, or, you know, or check the status of a GPI or something like that. Then of course there's traps. An agent sent by an alert rather sent by the SNMP agent to notify the SNMP manager when an event happens. So that's an alarm basically. And we don't currently use traps. You know, we do alarming in a different way, but we're not currently using them in our products.
Bob, I should know this, but is SNMP all UDP?
Is it all UDP? I believe it is, but Jennifer, help me.
Yes, it's all UDP.
Okay.
Thank you.
I thought I had the right answer, but I wanted to make sure. I don't like to give people bad information, but yes, I believe it is. Okay. Just a couple of the nuance here, but some but among definitions here. The difference between a get command and a trap. Get command is when command when sent asks for information based on the MIB for a specific request. So I want to know the whether, you know, GPI input number 3 is high or low, and there's a command for that. There's a get command for that, and the agent will send, the manager will send the get command, the agent will send back the data to tell you whether it's high or low, and that'll be a similar kind of a string. A trap, on the other hand, acts more like an alarm, as I said earlier. So when something happens, the agent says, hey, pay attention to me. So it's sending the trap information to the manager, and the manager, you know, that's without a query from the manager. So it's sending back an alarm. What's a get command to the equipment? It's an answer from any device, and a trap sends information back to the host when the threshold is reached or an event occurs, such as a failure, which is basically the same thing I just said. And I'm doing the thing that I hate to do, is reading the, you can read the PowerPoint just like I can. So here's an example, but I'm going to actually show you this. This is just a screenshot of a MIB browser, but let me attempt to share a screen here and actually show you how this works. So let's see if I can do this without messing it up again here. Let me stop the share a quick second here. Let me find my MIB browser. There it is. So that's what I want to bring up. Now, let's do a screen share here. And there it is. Okay, so this is a MIB browser, okay? And by the way, if you haven't gotten involved in SNMP, this is probably the handiest tool that you're ever going to have for managing SNMP devices and checking them out. And this is called a MIB browser. This one is a free one that we recommend and we use here at the shop. It's made by a company called iReasoning. It's just iReasoning.com. You can download this for free. They do have a paid version. It has some more powerful features, but this particular one is free and you can download it. Pardon me, as I said, from their website, and it's very handy for doing checkout. So what I've got loaded here already is basically this. What you're going to do is, I'm not going to go through all the mechanics of this, but you have to load the IP address that you're interested in, and then you have to load the particular MIB, which I've already done. You go find the MIBs that you want to load. In other words, let's go to the unload, and I'll show you what's here. I've got, looks like I got the iReasoning. Well, it loads its own application, and then there's two here. There's one for the DPS-100D, and there's one for the SWP-300. So let's just get rid of that. So we don't want to unload any of those. That's what's loaded. So as I said, you'll open this MIB tree up, and it'll look something like this, and you'll drill down, and here's Broadcast Devices Incorporated, and here are our registrations and product categories, and we have two here that are loaded. One is the DPS-100D, and the other one is the SWP-300. So you can go ahead and, well, let's see. You've already looked at the, let's do the SWP-300. Let's see if Bob can make a fool out of himself with this. All right, so we're going to open up the MIB for the SWP-300, and there's a lot of folders here. There's a lot of stuff going on. So I'm just going to pick one here just to demonstrate how this works. So if I want to look at something very simple like the status of the input, so I'm going to click on that. And so this is a status input. And I can click on the little leaf here, and I can, if I double click on that, it should tell me the status over here on the right-hand side. So it says that input status for input number one, the input is high. And there's a 2 after that. Well, what does that mean? Well, let's find out. So if we go in here and I right mouse click on this, I can do a set command, okay, which isn't really going to do anything in this case because this is a status input. This is information coming from the device to the manager. In this case, the MIB browser is the manager. So it's showing here that the input can be either high or low. There's an unknown state that's 0. Input, if the input is low, it's going to be a 1. If the input is high, it's going to be a 2. So that tells you what the nomenclature is supposed to be. But in this particular case, I can't really send a set command because there is no set command here. I'm doing a status. So that's, oh, well, here's a set command. I can change the nature of how the status will behave. Right now, it's set for when the input goes low, that it'll light the light. Most remote controls, you can vary that for either if it goes high, you want it to light the light, or if you want it to go low. So to change that, that would be this command here. So I'm going to do, let's see what state it's in right now. I'm going to do a get command to do that because I want to get information from the device. Well, there it is. And showing that it's a 1. So let's see what that, let's go and do a set command, then it'll give us the nomenclature. It'll tell us what we can do here. We can change, well, you know what? Why is that not showing? Let's try a 0 and see what happens. This may blow up. Oh, it succeeded. So now let's check it again. It's right there, actually, 1 and 0. So let's do a get. And it's still showing a 1. I don't know. I picked the wrong one to choose on this. Let me go. I'll go to one of the relays and show you how this works. But you get the idea. You can send a set command or a get command. I just happen to pick one that's not a good example here. But okay. So we can. Here's some controls. So here's some things that we can do. So let's pick one that's not going to embarrass the boss here. Oh, actually, these are. Well, I can press a button. I don't know what this button does yet, but let's do a get and see what. I keep picking ones that don't give me the, because some of these are not intended to really be done here. But let's go into unit control. Let's pick one that I know works because I've tried it before. So, okay, so TX to air. What this basically is, this is a little built-in macro that we have that selects which position the motorized switch is going to be in. So if I go to TX to air and I do a get on that, it's going to tell me that TX1 is selected to air. And this one's in parentheses. So that's what the difference is. That's going to tell me that there's another set of data there. So if I go in here and I do a set, it's going to tell me, okay, TX1 to air is 1. If I want to select TX2 to air, I want to put in a 2. So let's put in a 2 here. And do that. And I just heard the relay close behind me, so I know it did it. Move the switch. So if you're not in the same place where it is, you can go back in and do another get command. And now it's still showing TX1 to air. Well, maybe it was there already. Oh, I selected the wrong one, I think. Let me try that again. Oops. Oh, that's a get. I want to do a set. Did I push a 1 or a 2? I forget what I did. I thought I pushed a 2, but maybe I pushed a 1. Okay, so I hear that went back there, did something. So let's do a get. And it's still showing TX1 to air. So I got to go back and look at that. Maybe I have that jumpered out or something. But anyway, leave it to Bob to pick the things that don't seem to work right. But this is essentially how this thing will work. You can use this as a troubleshooting aid, so that, you know, like for example, you know, once in a while we'll get somebody that's trying to connect one of the power meters or one of these controllers to a Burke, let's say, and they're not getting any connectivity. Well, you know, we got to decide what it is. You know, is it the Burke that's not talking to the remote control or to our controller, or is it the controller not talking to the Burke, for example? So you use this tool to do that. So we know we're communicating with the device because we're getting data back from it. And here's the one for the DPS 100D. And this is mostly status in this one. This will give you this gives you forward power. Well, this is how this works in SNMP. This is interesting because this is going to give you the forward power in milliwatts. So, oh, maybe we're not connected to that. We're not connected to this unit, so we won't do that. But anyway, so that's basically essentially how the MIB browser works. And so I'm going to close this up before it embarrasses me some more. Okay, so let me stop sharing that and let me go back to the presentation here. Okay, so okay. Anyway, this slide is just to show you that we're using SNMP exclusively to communicate with our BDI stack software, which is another program that we offer free of charge, and is used mostly now with our audio product line. Because the controllers have their own application software, but and you can still do some things. Like for example, your DPS 100D power meter that is currently flash-based. If you don't want to upgrade it, or you don't have a chance to upgrade it, you can still access the information using the BDI stack, and that's using SNMP, and that's an application that's running on your computer. So you don't have to have a browser to monitor what's going on. What you are going to need, though, is you're going to need some kind of an interface to do any changes to the meter. If your browser can't access it. Now we do have what we call a Lifeline app, and that's something else that we offer to customers, and that's available through our dealer network. That allows you. It's a browser-like interface that can interface to the meter without using a standard browser. It's our own piece of software that basically will let you use a flash-equipped meter and still access it. Okay, so again, this is just showing this is third-party host equipment that you can have connected remote control, various remote controls. Our stuff interconnects directly together. We have connectivity to motorized switches with our controllers. So you can tie all this together with cables. There's very little soldering iron action or crimping tool action that's going on to interconnect all of these devices. All right, before I get to this, my final part of this, and how are we doing on time? Am I okay on time, or do you want me to move it along here? Hello?
I think yeah, I'm here. People are still here.
Okay.
And for people who need to leave, it's okay to leave, but we'll let you complete what you have.
Okay. All right. So, all right. Well, let me get through this because this is pretty quick. This is the third topic I've been putting in this presentation. This is multiplex over AES. And this is, of course, a new standard for passing FM stereo composite baseband, essentially from a stereo generator that's going to be co-located with, they have an Ethernet standard now too, I realize that, but this is really discussing the AES3 interface between, let's say, a stereo generator output and the exciter that you would input it to. Basically, up to now, most broadcasters have been not dealing with sample rates over 48 kilohertz. 32, 44.1, and 48 have been, pretty much have been the standard in radio, and television has pretty much been 48 kilohertz when you're dealing with discrete audio. How do you like that photo, by the way? That scope is right behind me here. That's an old 500 series scope. I love those old scopes. I have about 4 of them. I don't know what my widow is going to do with them. I think there's a big dumpster that will be filled up with them when I'm not using them anymore. But anyway, so this is an issue we got involved in a couple of years back. We had a customer that bought one of our AES switchers that has sample rate up to 192 kilohertz and was attempting to do multiplex over AES, and things were not working very well for him. And this was the first I'd actually seen anybody use this standard for anything. And we ship units to people and we don't really know what they're going to use them for. And this guy came back and said, well, this sort of works, but not really. And so he's trying to sample, send a 192 kilohertz sample through our device, which is rated for AES3 192 kilohertz sample rate. But, there's a lot of things you have to consider when you're dealing with higher sample rates. And this little chart here shows you the bandwidth, the system bandwidth that you're going to need for various sample rates. So if you look down at the bottom here, 32 kilohertz, you need about 20 megahertz worth of pass band to pass even a 32 kilohertz sample signal. Because if you look at the symbol rate and the interval, and you multiply all this out, it ends up being a bunch of bandwidth. So now let's go up to 192 kilohertz, and that's a whopping 122.88 megahertz, not kilohertz, megahertz worth of bandwidth that you have to have in your, whatever your transmission path is between where the stereo generator is, let's say, and the exciter. Well, most of the manufacturers of these stereo generators, which will remain nameless, are manufacturing these products with XLR connectors, which is the balanced 110 ohm standard. And I'm here to tell you that there's very few balanced cables, even the ones that are rated for 110 ohms, that can handle that kind of bandwidth. And that is principally the problem. So let's think about this for a minute. You're sampling at 192 kilohertz. That means you need to have about 15 harmonics worth of, about 10 to 15 harmonics worth of bandwidth to pass that signal. Well, why? Because mostly we're passing square waves. That's what these, what this stuff looks like. Square waves are very harmonic rich. And if you don't pass all the harmonics, the square wave ain't going to look like a square wave when it gets to the other end, which I'm going to show you here in just a second. So again, talked about the cabling, Belden 8451, which is audio cable. You can get away with it. You shouldn't, but lots of folks have done it. You can pass 48 kilohertz through it over short lengths without too much trouble. Greater than 48 kilohertz, Belden, has this 1800F digital audio cable, which is, again, is a balanced shielded cable, which is what the AES standard is. And then, of course, they offer 1694A, which is HDSDI cable, otherwise known as RG6, and that's a coaxial standard. So now let's look at some pictures. We did a little testing on this because we wanted to understand what was not working. And so what we did is we set up one of our units for both 110 ohm and 75. This is one of our AES402 digital audio switchers, by the way, what we're talking about. They're normally supplied with XLR connectors, although at an option you can get them with BNC, 75 ohm BNC. We've done it for customers in the past. And frankly, if we don't know what you're going to use the unit for, if you order a model number, we ship you a model number, and that's what you get. But anyway, we set these two units up, one with 110 ohm and one with 75 ohm, and we used 30 feet of cable. On the 110 ohm side, we used the 1800F equivalent 110 ohm balanced cable with XLR connectors. And the other side, we used a 30 foot of 1694A 75 ohm cable with the proper connectors. And what you're seeing here on my antiquated Tektronix, my slightly newer than the previous Tektronix scope you saw, is those waveforms that are at the load end. And these loads were terminated in the characteristic impedance. You'll notice on the left-hand side, there's quite a lot of jitter and quite a lot of overshoot. Well, overshoot, I never liked that term overshoot because that's really not what it is. I'll show you what it is here in a minute. But you notice on the right-hand side that while there's some rounding, which is a bandwidth limitation really in the scope, the little secret here, I didn't use a scope that had enough bandwidth. It's a 100 megahertz bandwidth scope, so it means it's 3 dB down at 100 megahertz. But it looks a whole lot better, as you can tell. There's very little jitter, and there's really very little so-called overshoot. The rounding is due to the bandwidth limitation of the scope, for full disclosure. So let's take a look at what's happening. You notice this is just a 100 hertz square wave, audio square wave. And you'll notice this, what looks like overshoot and undershoot on the leading and trailing edges of the square wave. Well, if you look very carefully at that, what that undershoot and overshoot really looks like is a sine wave. That's because it is a sine wave. Now, this is a 1 kilohertz tone that's been passed through a 4-pole Butterworth filter with a low pass of 1 kilohertz. So what's happening is you notice that the overshoot is approximately 1 millisecond in relation to time on the bottom there. Well, that's about 900 hertz. That's the 9th harmonic. That should be, what am I saying here, 900 hertz. Yes, that's the 9th harmonic of this waveform. 9th harmonic of a 100 hertz square wave. What you're seeing is this thing that's not arriving at the same speed as the rest of the harmonics. We call that envelope delay error or group delay error. When everything doesn't travel through the transmission path at the same speed, you're going to get this piling up of waveforms. And you can have worse situations if you have more harmonics and the bandwidth is more restricted or whatever the system is doing. So, it's square wave analysis of things, even at audio or at RF, is really very interesting. And what we're talking about here is RF, because by the time you're looking at 122 megahertz bandwidth, I think you would all agree that that's considered VHF RF at that point. So this is what's happening. This is what's causing the overshoot, bandwidth limitation. This is just showing another way. This is just showing that in the time domain and the frequency domain. Of course, we know that the square wave is made up of various harmonics, and there's two aspects of that. There's time, the phase relationship, and then the amplitude. So in a perfect world, everything is traveling at the same speed. So there's a perfect phase relationship between the harmonics, and the amplitude is basically based upon, the amplitude distribution is based upon the bandwidth. Now, let's take another look. We've superimposed the same square wave, but now the green, we have a red, I don't know how easy that is to see, but the red waveform is the original one that we started with, which is the 1 kilohertz waveform that's going through that 1 kilohertz filter. And that's a Butterworth type filter, which is going to have some phase shift at the 3 dB point, and that's what's causing the overshoot. The green is a Bessel response, and I'm sure you all know that that means it has a linear phase response, excellent step response. So there's very little group delay. And so I got here, think coax, because that's what coax is. Coax has basically has linear group delay. It has it has an equal envelope delay. That's why all digital television broadcasts now, the transmitters that used to have waveguide being connected to them are now using coaxial cable, because you can control the phase shift and the envelope delay much better with coaxes. It's predictable. So now what we've done here is we've what did we do here? This is another picture with 75 ohm termination. Now, we used two different processors from two different manufacturers. And again, I'm not going to tell you who they are. There's not that many, so you can guess. And this is the same waveform basically from each one. And there's slight differences here. You can see one has a little bit of rounding and one has a little more overshoot. And we found that actually that happens to be the source. Basically the generator side have really different properties from manufacturer to manufacturer. It really depends on how they design their AES driver, that drives the actual line. So the RS422 transmitter that they're using, or whatever they're using inside the device, the designs are obviously very different here. And again, this is characteristic termination here, which is 75 ohms. So our recommendation really is to use coaxial cable when you're going to try to do this. Anything north of 48 kilohertz, don't use 110 ohm cable. Don't use balanced cable. We recommend that even if like in this case, what solved the problem is the customer, they sent us back the unit, and we sent them a unit that has coaxial interface. Matter of fact, I have one here behind me. This particular one is an AES3, which is slightly different configuration, but it's from the same series. And on the back, we put BNCs for the input, the digital ins and outs, and this is analog here. You can switch between analog and digital with this particular switcher, but so we can outfit it with that from the factory if you need that. So just, it was an interesting, we thought it was an interesting project to get involved in. We solved the customer's problem, and we actually got some phone calls from one of the manufacturer's salespeople saying, "Hey, what did you do to solve this?" And I said, "Well, this." I told them, kind of gave them the Reader's Digest version of what you just heard, and I recommended that they, one of the manufacturers I think is doing it actually. I think they're actually outfitting their stereo generators now with their processor with this integrated stereo generator with a 75 ohm interface. I recommended they do that because they're just going to have nothing but trouble with this. They're going to have customers calling and complaining about this. And sure enough, I started to get some phone calls from some of these guys. So we just think you should use 75 ohm throughout. And if you have to use 110 ohm, use a transformer. Get it down to 75 ohms. We use the Canary style, and they seem to work pretty well. And then do all of your stuff at 75 ohms, and then only up convert if you have to at the exciter. Most of the exciter manufacturers are also still only offering them with a 110 ohm interface. Whether they'll change that or not, I don't know. It depends on whether this format actually, develops any legs. I have a feeling it's going to be short-lived, but, we'll see what happens. Well, okay, that's basically the end of the PowerPoint, but, well, I'm not really quite done yet. I thought I was, but I'm not. I did want to touch on our remote control system tonight. Yes, BDI has entered the remote control business. We have the new SWP300 series remote control system, which I'm just going to show a really brief demo here because it is getting late. And I'll kind of try to run through this very quickly. The basic chassis, anybody that has an SWP200 will say, well, gee, Bob, this looks like an SWP200. That's because it is, except it's an SWP200 on steroids. We've added some extra boards, and we've revamped the software completely in the unit. But essentially, it is what is a departure from traditional remote controls. And here I go. Let me just take a drink real quick. We know that Bob has talked too long when he starts to cough really hard. This is the only remote control that's on the market that has an integrated motorized RF switch controller that's built in. So if you're going to build a site and you're going to have a motorized switch in your world and 2 transmitters, traditionally you would have a remote control, and then you would have to have an external controller to control the switch. And we've integrated it into one product. So right there, that's a real cost savings, because if you have to go out and buy a controller and you have to buy a remote control, you're going to spend a lot more than what you see here. And then we also have an expansion panel. The IOX24 expansion panel is just what it sounds like. It gives you an additional 24 channels of relay outputs, status inputs, and 8 analog inputs. The base unit has as I said, it has the motorized switch controller, has a dedicated control of the two transmitters, interlocks, and on-off commands. And then you have 8 status inputs, 16 control outs. 8 of those are solid state, 8 of them are relays, and then you have 4 analog inputs. That's the base chassis unit. That's this guy right here. And then you can add this plug-in panel. It just plugs into the rear of this. If you want to add it, it's a very simple addition. That's the presentation, but let me show you the GUI for that. Let me show you the graphical user for that. So let me get out of this. I got to stop sharing. All right, so now let's do a new screen share here. And the SWP, it is, I think it's this one. Let me see. Yes, I guessed right. Something's going right. Okay, so this is our SWP300 remote control. This is, again, a piece of software that we provide at no additional cost. That's another thing that we do that some of the other companies don't do. They charge you extra for SNMP, and they charge you extra for their fancy software to operate the unit. We believe that if you buy a product from us, you should buy an integrated product, and so we offer the software as part of the purchase price. So this is the basic dashboard screen for this thing, and I'm not going to go through every one of these tabs, but I just want to just briefly touch on some of this. This would be like a summary screen that you would have. This could be viewed by an operator, or be up on a monitor in the studio or in a master control, and you can have multiple copies of this open for different sites, as a matter of fact. But this is what it is, the dashboard view, or the dashboard tab, which gives you an overview. In this particular case, we have 2 power meters connected. Oh, you notice that power meter that we had, the 46 kilowatts? It happens to be also connected to this remote control. You get all the parameters for 2 power meters here. One is on the main path, one is on the dummy load path. This is a 2-switch controller. So we have 2 switches here. So you get a view of the positions of the switches and the status. And you notice the power measurement is right where it's supposed to be. That's actually where the directional coupler is in the line between the two switches. And then you have another meter here, which is showing no power because there's the Gates air transmitter apparently is turned off, but the Nortel is running 46.1 kilowatts into the main antenna. A few other things that we have on this screen. We have some presets here, which are basically macros that you can set up. I'll just show you that briefly here. And this is kind of a smattering. Obviously, this is an FM station here with the Nautel and the Gates Air. And then you have a day pattern, night pattern. So that's an example of what you could do for, setting up your phaser if you have a day and night pattern and non-directional. And then you have 5 other buttons there that you can name and you can create macros for. We have some dedicated functions. We call them the SWP functions. So these are not going to, one of these is not going to work right now. And I'll predict why it won't work here in a minute. And this is one of the features of integrating the DPS 100D power meters with our remote control. If I wanted to switch from the main transmitter, the Nautel here, to the Gates Air, I'm going to try and do it, and I can tell you that it's not going to let me. It's just going to sit there because it's going to open the interlocks. It's going to try, but then it's going to say, Why? Because there's power applied to the forward power on that meter that's in between the 2 switches. It won't let me switch. So now if I walk over and I shut off the generator that's simulating the 46 kilowatts, then I can move the switch, but I'm not going to do that. I can't move either switch right now because unless I shut that power off. Now, of course, that would be integrated into the transmitter. When I call to move the switch, it would open the interlocks to both of the transmitters, and it would do a TX off, and then it would move. Then it would look at the power meter and make sure that it's not there and the power's not there, and then it would allow the switch to move. So that's what we call the smart switch technology that we've always had in our power meters and motorized switch controller product for years. We've been doing that. So we integrated that into the new product as well. A couple of other things that are here. You can have the main air, whichever transmitter is selected to on that is on air. Actually, you can turn on and off with a pair of buttons here. There's an auto manual switch here. This is right now in the auto position. So if I went over and I shut this off, shut the power off here, it would wait 15 seconds and would switch over to the other transmitter. And of course, I can defeat that. I can just put it in manual if I want to. And then a few of the other things that are here. Nope, I hit it twice. So, well, there it goes. These are statuses for the 2 transmitters. If you have transmitter on status, you can feed that to the unit and it'll display it here. And then there's a fault reset. A couple of other things really quick here. As I said, this is an overview. So this is a fully blown unit that has the internal stuff in the chassis, and then we have an IOX panel added here, and that's what you're seeing here. This is basically a kind of just a quick monitor, a glance, how are things doing. Like here we have 4 analog inputs, and it looks like we have this one set for transmitter 1 PA voltage. So we were like, well, that wouldn't be Nautel. That would, geez, PA voltage. I don't think they've ever built anything with a tube in it, but in this example, and then we have, this is the PAI. This looks like it needs a little attention here because there's an up arrow. I'll show you what that means in a minute. Room temperature and fuel level. And you say, well, Bob, I can't see any of that stuff. Those are things that I would want to indicate, and I want to look at the level of. Okay, so let's do that. Let's go to the control page, and let's look at those analog inputs. And there they are. So you have 95, 163 volts. We can see that that's within the normal window here. The little green is the parameter that I set up for warning, either high or low. The plate current is at 2.883 amperes, and it looks like it's probably getting above the range. I have to look at where I have that set. Room temperature, fuel level. These are just a few examples of things you can do. Everybody's dealt with analog inputs. We still do analog inputs on a remote control for these kinds, for legacy kind of products. Most new transmitters, it's SNMP. You're going to use their GUI to monitor and control it. You don't need our remote control to do that. So we offer the basics for either legacy transmitters or the basics that you would need. Even switch the Nautel because you need to still turn it on and off, and you still need to open the interlock. So those things are still hardware connections. Real quick, let me just show you one thing here that we made. I like this. We worked hard on this. I drove Jennifer nuts with this, getting this right. But the IOX analog, if you want to go into the setup here, to show you how we set these up. So here's an analog input. This is the channel 1 here. So if I bring this up, I can do a test gauge. I got to get this out of my way so I can see. And you'll notice that over here on the right, there's an A to D converter. This is the actual voltage of the sample that's being fed to that A to D input. So what I'll do is I'll clear it out, and I'm going to put that in, put it back in again, 483, and that tells the unit that that's the sample, the actual sample. And so I can go over here and I can set my parameters up for what I want. I've already done this already, so I'm not going to do it again, but the minimum sample is 0 to 0.5 volts. You can see it's near the top, and that makes sense. The display minimum is 0 volts to 9900 volts, and it is voltage, so I can put that in here, and I put my fault and warnings in here, and that's going to define where this red and green and yellow will be. If it gets into the warning, the yellow will appear to show you that it's in the warning. And so then you just save that, and you're done. So, you know, remember the days when you'd have to, you put the sample on there, and you'd say, well, I want it to read, you know, 9,000 volts, and then you test it, and it would come back, and a voice would say, the voltage is 8.5, you know, 8,500 volts, and you have to play with it some more to get it. You don't have to do that. You just put the voltage in here, set it for what you want, you're done. You do that on every input. You can name it, and you're finished. And by the way, this is about as rough as it gets to set this unit up. Set your general purpose inputs up. You can name them. You can set them whether you want a low going or high going, but you can hit it for invert for high going, and a light to light or low going. General purpose outputs, you can give them names. You can latch them or have them momentary. Same thing on the relays. The RF meters, you can give them names. This lets you name the modes of the switches. What else can you do here? You can name well, it looks like the dummy load and whatever. You can name a few more things here. This is as complicated as it gets. You've just set up, you know, very quickly. I've just shown you how to set up an entire remote control in about 5 minutes. There's no complicated software to learn. There's, you know, you don't have to sit and read a lot of manuals or sit online waiting for support. You know, you call us for support, you're probably talking to this guy right here most of the time. I may pass you off to Ron, or very rarely to Jennifer, but that happens occasionally. But pretty much I handle most of the support here. And it doesn't get any harder than this. This is really pretty simple to do. Just tell you about macros. Here's one that's set up already. This lets you do some pretty complicated stuff. I have this set up to do the day-night pattern switching. So button 1 is to set the, I guess it looks like that's to set the day pattern. That's the name of it here. So we're going to do a couple of things. We're going to set a relay. When we initiate this, the first thing that happens is the first relay of the SWP unit will toggle. And then we're going to set the button to the right color, because we picked pick green to be the active pattern, or whatever's on, you know, online. And then we're going to obviously set the other button to red, because that's gone offline. And it looks like I'm doing a few other things here. I'm taking a reading of the plate voltage, and then I'm sending a report of the pattern change. Now what that is I can go in here and I can show you reports. And here's the report for the day pattern, phase, and ratios. And, you know, you can go in here and you can, so this is what I want to measure. I want to measure all this stuff. Okay. And I didn't actually select the ones for the phase and ratio. I can name these, by the way. These would be on the IOX, because we're out of channels here. So let's say I want to look, let's say it's a simple 2-tower array. So we only want to look at phase and ratio of the second tower. We know what the reference is. And then we've edited it, and we're done. And that's set. And so it's going to take all those readings, and it'll send a report. It'll have it available to you. So that's all done in one macro. So that's how we do macros. They're very simple. And I was asked on a previous one of these, can you trigger one macro from another? And yes, you can. You can do that. So anyway, then we have a scheduling thing here. So like you want to set your day and night pattern. I keep going back to directional antenna stuff, because it's some typical examples. You know, everybody knows that you have to switch your patterns on a monthly basis, the time, you know, the local sunrise and sunset. This lets you set that up. You can go in here and you can set monthly times up for something to do something at a certain time and date, and have a change over at the month. So I'll let you do that kind of thing. Time of day things you can do, you know, your basic VCR clock timer kind of stuff in here. You can have it close a relay at the same time every day at 3 p.m. or whatever you want to do. Very much, you know, like anybody else would let you do. And that's pretty much it. Logging. Yes, we do logging. Oh, we got a whole lot of points to log here. And this thing's been taking readings since, looks like, oh, I don't know, we've had this one powered up since, looks like the last week in September. So it'll log all these points. This is stuff I have it set to log periodically. And then, of course, you can generate a CSV file, and you can save it. And, you know, you can do all the same stuff that you can do with the more expensive remote controls, I think. I think for a basic system, what you see here is about $3,000 to get started. and then the IOX panel is another, you add another $1,000 and you have a, we believe probably one of the best values, because if you consider with the other guys, you're going to spend $3,000 for their medium price system. And then if you need a motorized switch controller, they have a really expensive one now that they're offering through Dielectric for like twice what ours sells for, you know, a standard motorized switch controller. I think the list price on the thing is like $3,800, and it's SNMP. And they're trying to tell everybody that they were the first ones to have an SNMP based motorized switch controller, and they didn't. We had one 2 years before they did. Our SWP200 has been SNMP for a couple of years now. So anyway, I won't tell you who they are. You know who they are. So I think I'm pretty much done. I'll open this up to anybody. Anybody has any questions? I've probably left. I always think I've left out stuff. I'll wake up tomorrow morning. Oh, I should have said this. I should have mentioned that. But that's pretty much what I got to tell you. That's the story I have. And Dan, did I spice it up enough? I hope I did. I hope I made it a little bit different than what we saw in Baltimore.
Hey, Bob, I think Dan had to leave us, but
I don't have the other screen up, so I can't. Well, I can stop sharing here, so I can say goodbye to everybody, I guess. Or.
But we still got a group of 16, which is pretty good.
Oh, good. Wow.
So I'm just wondering if
but
anybody else has questions.
I noticed that everybody turned their camera off. So what does that mean? They're asleep. Okay. Questions?
Does anyone have questions for Bob?
Hey,
And
Bob.
don't forget you're all muted, so unmute if you have a question.
Yes, Mike.
Yeah, hey, good to see you. When we have SNMP issues with any product where maybe you can't communicate with the device, just in your experience, what are some of those circumstances that lead to that?
Well, other than the standard, Ethernet kind of connectivity issues, one of the things that could be can plague you, and we've had this happen to us occasionally, is if you have the wrong MIB. In other words, you're using an older version of a MIB for a product, and you've got that loaded in, and it doesn't know how to recognize the OID strings. That's one thing I can think of offhand. There are probably a lot of others, but again, that's why that browser tool is a very handy thing, because you can kind of point in which direction where the problem is. In other words, if you can interrogate the device that you're trying to communicate with the MIB browser, sort of midstream, that device is communicating properly. At least it's responding to requests. So you have to look in the other direction. Send the manager a request, or send it some status or whatever back. I mean, that's why the MIB browser is very handy. But I don't know. Did we lose Jen? Jen's still here. Jen, can you think of any other typical things?
There are some internet suppliers that filter out SNMP. You have to specifically request it.
Right. That's one of the obvious ones but that I forgot. Matter of fact, Jennifer works remote, and at her location, she had a heck of a time, getting the internet service provider to give her the right service to be able to do SNMP. We were going to really have a problem if she couldn't communicate with devices that are up here in New York. She's down in the Nashville area, and so that's and I didn't think of that one, but that's a pretty obvious one. You've got to have good service, particularly if it's most of you are probably running on VPNs, and it's intra facility, and so you probably don't run into those problems. But again, ports that are locked out and things like that, the obvious stuff, which is it's going to stop anything from working. By the way, this is something that a friend of mine and also a customer, not for our remote control. I'll just tell you a story. I don't want to say these things to tell tales out of school, but this is real experiences that people have had. He bought a very expensive package from, the largest remote control manufacturer probably in the United States, and we know who that is. And again, I'm not saying these things to, it's not anything against their product or anything like that. It's just, I think the methodology that they use perhaps is a little different than what we do. So for example, they have a base unit, And then you have these satellite units, I'll call them, that, you have the, relay outs and the status inputs, and you can locate them in various places. And they're all connected, through Ethernet. Well, this guy he had a pretty unlimited budget. I have to tell you, this is an AM directional station, and this is kind of unheard of. He spent about $20,000 on the remote control hardware, and then probably proceeded to spend an equal amount of money for installation, because they had, electrical contractors coming in and running conduits to all of these cables and all this stuff that he wanted to monitor and everything. It's a beautiful system. But this thing cost him about 40 grand when he was all done. And one Sunday night, he gets a call from the studio. They're in a panic because they can't control anything. And he says, well, we can't see any of the anything that are any of these peripherals that are connected to the remote control. Well, it turns out that the IT department decided to lock out a whole block of IP addresses and ports, and they do this stuff on a Sunday night, and all of a sudden his remote control becomes pretty much inoperative. So they had to sort that all out, and the reason for that is because they're using Ethernet to talk to everything, and it sounds great. We don't do that with our peripherals. Our peripherals run either RS-45 or RS-232. Plain old simple. It just works, and nobody's going to mess with it. You have a cable that goes between equipment, and they're communicating back and forth, and there's no other traffic on that, on that cable. That's just talking to the peripheral, whether it's one of our IOX panels or one of our power meters. I mean, certainly we use Ethernet. You have to get to the outside world, but we try to limit the exposure on that. So that's a little difference in the way in which we approach, how we attach peripherals to things. Admittedly, we can't build a system as complex as they can, but that's not the market for our product. Our product is the guy who needs to build a transmitter facility on a budget. We envisioned, for example, the translator market, where iHeart was building out a lot of translators a few years ago, buying lots of our switch controllers and essentially using them as remote controls. And we thought, they're onto something here. They're buying a very inexpensive device to control a motorized switch, to control 2 transmitters. They only really care about the one that's on the air. They can turn that on and off with the controller. And we said, well, why don't we just add some more remote control capability? We have plenty of room in the chassis, plenty of holes on the back panel. So, this is what we ended up doing. We built on that platform, and we knew that hardware works pretty well. We've been using it for, we've been building controllers now for, I think 2007, something like that is when we started doing that, 2008, somewhere in that neighborhood. So we know the hardware is bulletproof. It works pretty well. It's pretty proven, and we just built on that platform. So yeah, the other system is probably more flexible, and you could add to it and have a really complicated system. But there's a segment of the marketplace that doesn't need all of that and can't afford it. So, that's the market for this. It's the guy who's really got to stretch the dollars. He wants to spend the money wisely, and that's who we're targeting this product toward.
Thanks.
Okay. Well, and Mike's a good customer. As a matter of fact, let's see.
Joe as well.
Joe and Gary. Oh, Gary turned on his camera. Hey, Gary, I haven't seen you in a while. What happened?
Got a little thin up there.
Oh, well, I get to gloat because, and it's all mine too.
Well, I got to tell you, it takes no work. I mean, you just take the towel and
Yeah, Gary actually is one of our early customers for the controller. He said, you've had SWP200s at your facility for a lot of years, right? And how's our
a
service?
couple of them I still do.
How's our customer support? I'm going to put him on the spot here. Oh, he went away.
What did you
Turned
say?
off
I'm
the
sorry.
video.
What'd you say?
This is where he's sticking his tongue out at me. No, I think we do a pretty good job with support. I don't know. Some companies, sometimes it's a funny thing. I sometimes when I answer the phone, people are actually shocked, number one, that anybody actually answered the phone, and then they're going to get help, they're used to waiting for support. And I just think that that's a terrible thing. We try to, we try to answer calls very promptly and try to get you answers and get you squared away as soon as we possibly can. We're not perfect like everybody else. We make mistakes and things happen and people have had issues, but we like to think that we've built some pretty good long-term relationships with customers based on our support sometimes. Sometimes it's the one that, you know.
Support is very good and maybe too good sometimes to your own detriment.
Yeah, because a lot of companies will tell you, hey, Gary, you need a new one. Just buy a new one. And I don't do that to people. I try to help you stretch your dollars. And that, by the way, is, you know, we have several upgrade programs, by the way, because all of our Ethernet, based internet accessible products that were SNMP, which is our audio product line, the audio toolbox product line, the SWP series, the power meters. We have upgrade programs for all of them. So if you have any of the flash-based interface for your SWP 200s, we can have even if you have the old serial over LAN interface for that, you know, the old LAN board, we can upgrade those to SNMP. I think, didn't we do that? Well, we didn't do that. I tried to convince Gary that he should do that on one of his, and he said, no. But we can do that. You can actually send us a controller. We can do that with the audio switchers as well. If you have one of our audio switchers, even if it doesn't have a LAN interface at all, we can upgrade that.
You kind of helped me out. We upgraded the software, but we didn't change all the guts out.
Well, yeah, that's because you didn't want me to. We could have given you the LAN, you know, the upgrade of the LAN board, but I think you talked me out of it or something. But no, I mean, that just gives you an idea of the flexibility in the products that we make. You know, so if you have one of the older switch controllers that has we used to use basically to get to the internet, we used to use a LAN port made by Lantronix. A lot of companies use them. And they're great for serial over IP, but you know, they don't easily do SNMP. I don't think I've ever seen anybody make one work right using SNMP, but so that's why we went to a different platform. But any of the units that have those boards in them, we can upgrade them. We can make them SNMP compatible. So, you know, whether you got an SWP 200 or you have one of our audio toolbox, ATB 300, GPM 300s, we can upgrade all of those. They need to come back to the factory to do that, but we can do it. And with that, ladies and gentlemen, I am about talked out. Unless you have any other questions, I really need to recover my voice.
Always like it when we wear out the guest.
Oh, yeah, well, seriously, thank you very much. I mean, I really appreciate the time. And
well, Bob, thanks a lot for your time. I think back when you first started making those modules for the executives and the presidents, the guy I was working for bought a bunch of them, and we probably retreaded 3 or 4 consoles. And I think, matter of fact, you built some amplifier modules for an RCA BC7 for us.
Oh yeah, we did Gates executive. We did the RCA BC7 series. We did McMartin 800 series. All the modules in the McMartin console, those really forgettable designs that they had. And, you know, we really did a nice job on that one because you could, you know, I don't know if anybody ever run any of those, the old McMartin 800s, they had basically the monitor amplifier could double as a hot plate.
Yeah,
I had one.
The B802.
Yeah, well, there you go. The 801, 802, 803. The 802 was the stereo version, but we made these plug-in replacements that, believe it or not, work with that 130-volt power supply. But you didn't have to use it. You could. We regulated everything down to either 30 volts or 36 volts. What a crazy idea that was.
A lot of one of those made that time was like that. It used a 130-volt supply, and then they just voltage divider down for every board in modulation monitors were like that too.
Yeah, they had that big, yeah, right. The McMartin mod monitor had that big string of power resistors, and they were always blown up, and you know. Oh well.
But it was certainly good to see and talk with you again.
Okay, well, thank you all for putting up with me for an hour and change here and allowing me to maybe hopefully enlighten you a little bit and do a little bit of selling, a little bit of soap here. You know, I always appreciate that. You know, the one bad thing about no NAB this year, and I'm just going to leave you with this. I don't know what the hell to do with all these pens. You need a pen, call me. We're throwing them in the boxes and sending them out to people. You buy a product from us, you're going to get a pen.
Hot dog. Well, Bob, I enjoyed it. I'll catch up with you later. Thanks a
All right,
lot.
Gary. It's good to see everybody. Good to see you too, Gary.
All right, well, thanks everybody for coming, and keep an eye on the website. We'll come up with something in lieu of the Christmas party, November, December. We will put some sort of program together.
Oh, one last thing. Speaking of websites, visit ours, www.broadcast-devices.com. We have a new YouTube channel. We have a Facebook presence. And I even think we have a Pinterest thing, which is mostly my goofy things that I like to save. It's not really so much technical, but so check those out. We have a couple of videos up there on some of the demos on these products. Some of them are actually out of date. What you saw is actually more up to date than what's on the YouTube channel, but there's some good stuff there, I think, anyway. So check it out. That's some additional resources from us. And with that, I think I will say good night, gentlemen and lady.